Okay, so this is lesson 2 of Unit 6 on solving linear systems. Um, the purpose or the objective of this lesson is to give a second algebraic or analytical method to solve systems of equations. Of course, we've learned in the previous lesson solving systems of or solving linear systems using a method called substitution. And what we'll do is just jump ahead very quickly to look at an example on the next page to show why it is that having a second algebraic method is helpful. And so you may recall from the previous lesson that substitution requires you to select from one of the equations a variable, either variable, but preferably one that has a coefficient of 1. And so in this case, if you look at both of the equations, you see that neither of the variables in either of the equation has a coefficient of 1. Of course, we could fix this by dividing through, so we could get the coefficient of x to be 1 by dividing through by 4, but the issue with doing that, of course, is that we are then going to introduce fairly complicated fractions that we will then have to substitute into the next expression and work with. And so one of the major factors or advantages of using the elimination method is that it can limit, not completely eliminate, but definitely limit the need for us to work extensively with fractions. And so let's go back and just focus on the mechanics of the method. And so as before, we are analytically or algebraically solving a linear system, and what we're interested in is an x value and a y value, or an ordered pair as our solution, and so that remains unchanged. Okay, and so detailed here are the steps for solving linear systems using elimination. The first step of which is to rearrange into what you may recall is known as standard form, the standard form of a linear equation. And so the standard form involves rearranging the equations so that we have the x's and then the y's and then the constants on the right hand side. Okay, and then effectively what we're trying to do is to eliminate either the x's or the y's by adding or subtracting the two equations to each other. And what we need to do sometimes in order to ensure that they do, one of them does cancel out, is that we may need to multiply or divide first. Once we've eliminated one of the variables, the approach is similar to the previous lesson, where we solve to find the numerical value of the variable left behind and then substitute back. So let's see what it looks like in action, so to speak. And so we're going to solve the following given system. Our first step, as you can see, we have ax plus by equals c, but our second given equation is not in standard form. The x and the x's and the y's and the equal signs are not lining up, and so for this method that is of importance. And so our first step will be to rearrange the equation by moving the 3x to the left hand side, resulting in minus 3x. And so now what we can see from here is that we have our x's lined up, our y's lined up, our equal signs lined up, and the constants on the right hand side. Okay, and so what we need to do now is add or subtract the two equations in order to eliminate either the x's or the y's. Of course, if we added the equations as is, the x's would not cancel each other out, neither would the y's. And so what we're going to do to begin with is to multiply the equations to get the coefficients of one of the variables to be the same. So in this case, for no particular reason, I've picked x, and so I'm going to multiply the entire first equation by 3, so that I'm going to end up with the x coefficient of 12, and the second equation, the entire equation, will be multiplied by 4, and so that is to ensure that the x coefficient is minus 12. And so in this case I focused on the x's. I could just as easily have focused on the y's. Okay, And so we've distributed the entire equation, we've multiplied by the value 3, so 12x plus 15y equals 105. In the second equation, we've multiplied through by 4, leaving us with minus 12x plus 8y is equal to minus 36. And this allows us now to literally add the two equations. And so if I did 105 minus 36, I'd get 69. 15y plus 8y is 23y. 12x plus minus 12x would cancel, and I'm now left with an equation which has got only one unknown, namely y, and I can then divide through by our unwanted coefficient to get my y value of 3. As before, I need both an x value and a y value. I now take the y value of 3 and substitute it back into either of the given equations. I have selected the first equation, 4x plus 5y is equal to 35. In the place of y, we'll put 3 because we've established that as its value, and then isolate x, and we have our x value of 5. Okay, so what we'll do at this point is I'll take you through examples 1, A, B, and C to model what you need to be able to do. And these start relatively easily, and then at that point I'll end the first part of this video and ask you to work examples D and E, and also the word problem, and solutions to those will be contained in the video of the second part of the lessons video. Okay, so we're going to solve this system. Again, for all of these we'll use the newly learned elimination method. Okay, so in this particular case, what you can see, hopefully, is that the y's are already set to go because they've got the same coefficient, which also happen to be opposite to each other. And so we're going to go ahead and say 4x minus 2x is going to leave me with 2x minus 3y plus 3y. And so what we're doing is adding the first equation to the second. That will cancel out. Is equal to 5 plus minus 7, which is the same as 5 minus 7, which is minus 2. And very quickly and very easily in this case, we can establish that x is equal to minus 1. We do need to substitute that value back into either equation in order to solve for y. And so I'll use the first equation again for no particular reason whatsoever. We substitute in the x value that we found, and then we will go about solving for y. And so we have minus 9 is equal to 3y, divide both sides by 3, and y is equal to minus 3. And so again, writing that as an ordered pair, minus 1 minus 3 is our solution. Okay, and so in example B, just slightly more difficult, but once again what we can see hopefully is that the coefficients of the x's match. What we're going to do in this case, however, is we are going to, instead of adding the two equations, we are going to subtract the second equation from the first equation. And because we're subtracting, we need to be quite careful. We are effectively distributing minus 1 to the entire equation, and so we have 7x minus 7x, which is nothing, 0x, minus 2y plus 3y, which leaves us with 1y, and we have 5 minus 4, which leaves us with 1. Rather luckily, fortuitously, we've gone directly to a part of our solution, which is y equals 1. Generally speaking, the equations don't work out quite so easily and quite so well. And so what we'll do with our value y equals 1 is substitute that back into either equation. 7x minus 2 times our y value of 1 is equal to 5. And so in this case, 7x is equal to 7. We have a rather simple solution, 1, 1. But our method and our approach is the same. Okay, and now to the Final example for this part of the video, slightly more complicated in this case. What you can see is that our first equation is in the standard form, ax plus by equals c. The second equation is not. And so we'll begin by rearranging the second equation by moving the 3x to the left hand side. Becomes minus 3x plus 2y is equal to 6. Luckily again we have a plus 3x and a minus 3x, and we can go ahead directly to add those two equations to each other, and the x's will cancel out. We have 6y, and minus 6 plus 6 is 0. Divide through by 6 and we have our y value of 0. We substitute this back in. Again, remember, just because y is 0 does not necessarily mean x will be. And so I'm going to substitute back into the first equation. 3x plus 4 times y is 0 is minus 6. And so 4 times 0 is 0. 3x is equal to minus 6. And I'll divide through by 3 to give us our x value of minus 2, and again, as an ordered pair, minus 2, 0 is our solution. Okay, and so at this point your charge is to go ahead and attempt examples D and E and the word problem on the next page. After you've made an attempt at those, then please watch the second part of the video.